Hello and welcome back to 300 Seconds of Science. Now, a lot of cool things have happened since the last time we met, including the addition of 4 elements to our periodic table. The name's bond. Ionic bond. Taken, not shared. Let's get periodical. I'm Adam B, and that B is not short for boron, although we are talking about the periodic table of elements today. But speaking of boron, scientists actually added 4 elements to the periodic table. Now, the names of these elements are fairly confusing and not memorable at all, but no, they're temporary, and whenever we think of a more fitting name, it will be applied. These elements have a bunch of unnatural features, primarily because on Earth, we can kinda only make them in labs. Element 113 actually has a half-life of 20 seconds and is extremely radioactive, whereas element 115 has a half-life of 220 milliseconds. 220 milliseconds! Now, that doesn't seem very significant, but when compared to hydrogen, that has a half-life of 12 years, or plutonium, that has a half-life of 79 million years, there's a world of difference between those elements and the new elements. It's not hard to figure out why it's very difficult for us to even see these elements, seeing as if they are only around for less than the blink of an eye. Finding elements to put on the periodic table is not something that happens often. It's definitely a more exclusive list than the House of Congress. We talked to Alex about what it takes to be added to the periodic table.
So in order for an element to be added to the periodic table of elements, an element's identity is based off of the combination of protons and neutrons it has at its nucleus. You take 2 nuclei and you smash them together, and if they stay together for a couple milliseconds, not only do you have to prove that, but 2 different environments have to come up with that same result, and then it gets to be added to the periodic table.
So, the process is lengthy, but understand every contribution made to the periodic table changes our understanding of our world. No, our universe. So I wanted to ask Alex what impact finding these elements could have on our understanding of the universe.
So finding new elements for the periodic table would help our understanding of the universe, maybe just by giving us some insight on what other environments can look like. You know, it's hard for those new elements to exist on Earth just because of the hand that we've been dealt with our 1 atmosphere pressure. And when you can synthesize one in the lab, you're kind of setting the boundaries for where that can exist at. So in like high pressure, hostile environments where there's lots of, like maybe the death or the birth of a star, where there's things blasting into each other really hard.
As we understand what could potentially be out there, we become more equipped to live within this beautiful, beautiful universe. You know, these might not have the same impact as when we found radio waves, we found out atoms existed, or when we made the table itself. We open up a new realm of understanding with these types of discoveries. Finding more elements or materials to work with is a fundamental part of the human experience. It's how we got to where we are today. Nice job, science. Our understanding of what is possible has led us to every discovery we've made as a species, and we need to keep this kind of stuff going. It's essential. Although, where there have been a lot of discoveries in recent years is in the world of the subatomic particles. Now, these particles can be broken down into categories: fermions, bosons, leptons, and quarks.
So there's 2 different classes of elementary particles: half integer spin and full integer spin. Half integer spin, those are called fermions, and then full integer spin, those are called bosons. Half integer spin particles, those follow the Pauli exclusion principle, and full integer spin particles do not follow the Pauli exclusion principle. What the Pauli exclusion principle is, 2 of the same particle can't exist in the same quantum state.
This is a hard thing to understand, and we would need more of your time to go into detail, but essentially it is just how the different particles carry angular momentum. So many great things going on in the science community. Now, if you guys like science blurbs popping up in your news feed, you guys should like us on Facebook, follow us on Twitter, and make sure you subscribe on YouTube. I'm Adam Bonomo, and that was 300 Seconds of Science. So go out, enjoy life, and stay curious.